So I'm just starting. I know it's little late and it's 12:34 a.m. in the night, and so if anyone is going to watch it in future, I'm just saying good night guys, and let me see the videos if I'm streaming it or not, and after that I'll introduce myself, and after that we are going to learn the DSA, and there is one problem remaining in the expert section and we'll finish that, and after that maybe we'll target another chapter after and it's I'm pretty happy that for the first time I'm going to finish at least this driver shoots first topic, and that is DSA. No, not DSA, if you will say. Okay, so I think it's working. So first of all, let me introduce myself. So hi guys, if you are watching for the first time, my name is XYZ. I don't know. Okay, it's not good to tell me my name. At least at this stage, it's very bad. Uh, and name doesn't matter until you are doing something great. So for the time being, let me tell you why I'm streaming this. So the main purpose of it is to be consistent. If you it feels like someone is watching to me, or someone is going to it's kind of thing that I'm building. It's a, you can say, surroundings that I'm building, or maybe you can say an environment that I'm creating around me. uh, is like someone continuously monitoring me, someone daily watching me, or someone daily monitoring me whether I'm showing my presence or not, or maybe whether I'm you can say consistent about what I'm learning, and if not, then what is the reason for it. You have to come and you have to tell. And I'm on a mission to to learn the DSA by heart. Until I'm not gonna finish it completely, I'll have to show the presence daily. At least I'll try to solve one problem every day. It could be simple, it could be hard, it could be difficult, or it could be expert level problem. Irrespective of problem, I have to finish one problem each day, instead of irrespective of any circumstances. It could be I'm sick, it could be I'm in hospital, I don't know, I don't care about anything, just I need to finish the problem. And the reason is simply I do not want to break consistency. Even if I'm unable to solve due to some reasons, then I'll solve a simple problem that I already solved, but I'll do it. The main reason is, if you see here, it's day 17 and we are continuously, so max streak is 17, if you see. So that's pretty much great thing and positive sign that we are moving and we are proceeding up, we are making progress, and it is great sign that you are in the right direction. And if you are also watching, and if you are planning or you are learning DSA, just go for it without wasting your time and all, and do not repeat the same things again and again. If you know, in the coding also there is a principle called dry principle, and that means do not repeat yourself. So suppose I finished this section and after that I stopped, or I just took break, a longer break, maybe 1 month or 2 months, and after that I'll come back, then I have to repeat the same problems again and again. It's like you are uh, part of a loop that is never gonna end. You will start something and after that uh, you will stop it before completely finishing it, or before finishing it, and you will again have to start from beginning, and the loop is never gonna end, and you will be trapped and one day over everything. You not have permanent time to learn DSA or something. When you will be 60 years old, you do not have uh, capability to learn DSA. Maybe you have memory, but what is the benefit of it? Most of the IT professionals are working there, have career of 40 years and 45 years, otherwise they will be only the top level and there are only few people. So our goal is to learn and just utilize the DSA as much as possible. And it's not about DSA, I'm also planning to learn system design, and planning is very bad thing. Like you always, or I used to say, like I'm planning to do this, I'm planning to do this, that, and all. But what about those? It won't work until you are not executing them. Plans are, everyone makes plans every time. Like you will see, first Jan 2020, like every new year, people makes new promises. Like I'll do this year. But what If you'll ask on 31st December, then you will get to know like most of the plants got dropped off within 3 to 3 months, and if someone is very consistent, then next 6 months and so on. And no one, very few people are there who are committed to what they have planned on 1st Jan, or maybe in the new year, you can say. So that's why it's great if you are watching or if you are making a great progress. But yeah, we are here to learn. And so okay, let's jump now. We can jump into the topic. And I today I'm just targeting one problem, and I have only one problem to solve in the expert section. And tomorrow onwards we are going to solve bind research. I believe there is another section, and simultaneously maybe in the weekends I'll try to learn the, you can say, dynamic programming, and I'm gonna refer the Aditya Verma's video. Maybe let me show you if you are watching, so that you will get help before I jump to the problem solving. So he is a fantastic tutor for the dynamic programming. Definitely I'll recommend it. If you know this person, he is a great tutor. Really I respect for the way he taught the dynamic programming. It's great, fantastic, super. I'll say super lectures are very intuitive, and you will get to know patterns and all. He tried to taught it in a manner that should be taught, uh, like I'm just expecting, like it's the way that he taught those topics, very like complex topics, into simple way. It's fantastic, superb. I'll say yeah, 10 out of 10 I'm gonna give if you have to ask. By the way, I'm not person who can give rate him, but definitely I'm saying as a person, you can say. So now let's jump to the problem, and let me see if it is working for me now. QuickTime Player, let me open it, and I'll start new screen recording, I mean new movie recording, and it will open. And yeah, so now everything is ready and we can jump to the problem. So reverse pairs, okay, great. It's a hard problem. Given an integer array nums, return the number of reverse pair in the array. Great. An index pair ij is called reverse pair if, okay, I greater than equals to 0 and j is greater than I, and nums of length of I greater than, man, what is this? Okay, so first thing is, you can say I and j are between 0 and length of array less than 0. It could be between 0 and j will be always greater than I. So we can say, no man, you can have to change 40% to 100%. And nums of I is nothing but nums of so first thing is j will be greater than I, and if we are talking about the value, though j is greater than I, okay, so j will be in the forward direction as compared to I. But if we are talking about the values, then the value of I is almost greater than twice of j. So don't you think it's similar to the previous problems? And here this one will be I, not I. You can say this I, and j will be, if suppose j is nums of j. So can we say the number, the reverse pair will be, so the reverse pair, okay, let me just walk through the, I mean, yeah, 1 minute. So I'm just sharing my screen, just 64127. Great. So we have these numbers, okay. I think we are going to use it in the same type of 5, 4, 4 and 3 and 3. Let me jump to the first. So we have these numbers. First thing, j will be always greater than I. So if we are talking about j, then this if I is 0, then z will be greater than this, and all the numbers that are greater than is. So can I say for I is in this location, so j can be in these different locations. So what was the value of it? I just wrote something gibberish, garbage, 6 4. So this one is not working because yeah, it's not double of it. So 4 to the greater than 4 double should be 8. This no, this 2 to the 4. So we can say this is one condition that is matching for j, and 7 won't work. So we have 6 comma 2, one pair. Now we are going to move to this number 4. 4 is 1, so 4 comma 1, and 2 to the 4, no it won't work. 7, no it won't work. Then we are going to jump to this 1. So this one won't work with these numbers, these are all greater than this number, so this won't work. Then we'll jump to this number 2. What about it? No, it won't work. So we have only 2 pairs, right? Zero 6 and 0 2. 0 and 1 2. Okay. 0 and 3. 0 and you can say 0 and 1 2, 0 2 and 0 3, and then 1 and 2. So these are the numbers. Okay, I think let me see the numbers first. What are the constraints for it? So numbers can be negative. Great. Six. So we have numbers like 6 4 1 to 7. Great. So now we need to change. No man, we need to jump, and we need something, some sort of solution where we can see this version is. So we just based on value, how can we decide like whether the number will be. Simply let's see, can we solve it using I do not think like this way we will be able to approach it. So we have 6 4 and 1. Great. We have 2 and 7. Now we just split it into 6 4 and this is 1. Now it will be 6 and it will be 4. So these are the numbers, and here it will be 2 and it will be 7. Okay, great. Now if we have to compare these two numbers, we need to merge them. But before merging, can we compare? If this number is greater than this, then that number will be, basically this will be pair with this. So can we say no, 4 and 6 we can't say, like this is not twice of this number. So yeah, so we can say 6 and 4 won't help us. So this one will be this, and now we are getting this one. Okay, so now we need to compare. So when we are comparing this number, how are we going to tackle it? Sorry, my bad. 4, 4 and 6, these are the numbers. Now when we are checking first number, we are comparing I and C. So if J is first thing, if this number is greater than twice of this, suppose this is you can say 1. Okay, so this number is 1. I do not know how to choose it in a perfect way. Leave it, man. I do not. Okay, so here we have 4 and 6, if you know. So now we are going to compare first and second word. So if you notice, this is a smaller number and this is bigger number. So can we say in the left side of array numbers are larger? So now the only challenge is it greater than the twice of it? Like this number is twice of this, greater than twice of it? So yes, so this number is basically 1 and twice of it will be 2. So it's, the number is greater than 2. Yeah, 2 twice of z, definitely. If this number is greater than this number, then all the numbers that are following it will be also greater than this number. So can I say where I is present, okay, but only challenging part here is, you know what, so suppose this number is not bigger number. Okay, so what will be happen? So this is bigger number, so it will come at first location, and when we are swapping it or when we are placing the number, so all the numbers that are smaller than it, maybe twice of it. Okay, first thing is we need to check. But only problem is here when we are swapping the number, we are swapping it with this number, so we'll get to know. Okay, if the number is smaller than this or it is bigger than this but it is not twice of it, then we need to check another number, and that's where problem will arrive. You got it? Suppose here we have 2, and let's take hypothetical situation. We have 2 and 6. Okay, now if we'll compare, bro, are you greater than me? It will say no. Yes, I am greater than you, but still I'm not twice of you, so you can't come assume that all the numbers that will be after me will be greater than me. So yeah, all the numbers will be greater than me, but you can't say or you can't confirm or you can't make a prediction that the numbers are twice of me or twice of you, greater than twice of you. So only when we will get that condition if the first number is greater than this when we are comparing that number. And if we are going to compare with each number, then that will be the problematic situation here. So one thing I'm thinking, maybe let's say we'll be having 1, then we'll be having 4. We'll got the first number. Okay, after that we'll see the remaining part will come here. But when we are comparing the remaining part, how can we make sure that all the numbers are being counted if they are greater than them? So maybe 4 will be placed here, and then 6 will be placed here, or maybe let's say 2 is there. Then what if there are numbers like 4 and 6 and 1 and 8. Four to 6 and let's say 2. 4 1 2 6 8. This will be the case. First this one will be calculated compared with this, so 1 will be placed, and for 1 this number is this. Okay, I know for sure we need to do something to get the count of this number, and for that if we'll start scanning from it, maybe one first we'll check with this number, then we'll check with this number and this number, and so that can be case like order of n. And if we will start checking every number, then that means that won't help us. Okay, oh man, I'm just thinking, I think I'm just stuck in with the same approach. Let me add timer of 45 minutes, though we are so 1 will be compared with 2, so we'll say okay, 2 is bigger than 1. Actually just we need to check the numbers that is greater than twice of it. 2 times this. What if we'll make it twice? We do not want numbers, right? We just want values, count. Can I say 2 and it will be 2, it will be 8. So first this one will be there, then 6, 2 will come again, so 2. I know we do not need to take 2, we'll take okay. The problem is if we'll take 2, the problem is here if we are taking the number twice, so that will be like 2 2, 8 will become 16, 2 to 6 16, and we know so how many numbers are greater than this? We'll compare only one number. And how many numbers are greater than this? No, so 16. If we are making twice, then definitely we'll get to know count for this one purpose. But what about when we need sorted array, so that we can make a conclusion from another array? And we'll take it one, imagine 2, we take we need some sort of 1 2 6 8. So this is what we are expecting. Then only we will be able to calculate with another part of it. Six one four to 7. Okay, so for 6, it's like find all the number that are lesser than, not this. For 6 less than 3, all the numbers. 3 less than 3 numbers will be 1, this one only. Yeah. And for 1, all the numbers less than, you can say 0. So there won't be anything. 1 by 2 means 0.5, and you can say less than 0.5 means 0 or less than 0. So there won't be any numbers. Okay, so for it, when for it, no man, this won't work. Okay, do you have anything that you can use? I know 3, and we need to look for all the numbers that are less than 3, and you will get 2. So 0 comma 0 1 2 3 4. So less than, so it will be 0 comma 1, less than 3 numbers, and 2 0 comma 3. And if you are talking about 1, so there won't be anything that is less than 1, 0, I mean 0 or less than 0. And the 4 will be all numbers that are less than 2. 4 means 2, so less than 2, no 1 will be there. 4 to all numbers that are less than 1, and it will be 7 only. So 0 3 comma 4, I got it, but how are we going to check it? I know one option is like just start and check, start comparing, but that is like order of n square, and we can't solve it. The only problem is here. No, I'm just not talking about problem. I'm just taking 61427. This is our number, and here we need to perform the operation. If we'll 61, I'll split it into 614 and 2 and 7. Now just I want to split it into like this. 61, man, I just need it anyhow. So 2 will be here and 7 will be here. But problem is how I'm going to suppose or assume 6 and 1 will work. I mean, this is for okay. Here we can say like if there is any number less than this. I know this is the place based on which we can count. For example, if suppose this number, here we have 6. So all the numbers that are less than 3. So can I say 2 of this number will be this number is greater than this. So yeah, so we know this number is greater than this. Okay, that is okay. But what if it is not greater than this? I mean, once we'll sort it, things will change. But if we'll use it like 3, no, it's not helping me to derive a solution. I'm thinking around one only option. I think we need to think more on it. I don't know, but like it feels like this is an option to achieve the result. So 164. So it's greater than this number. Okay, great. The number is greater than this. If it is 2 of I is greater than this number, I know 1 is okay, it will be discarded because it is smaller than this number, so that's okay. Now here we are getting this number that is larger than the remaining elements of array. So we need to check and we need to compare with all the elements of array. What will be the counts for it? And then we can get the count. Okay. And when we are checking for other, then also we can get the count. But that won't be something like, how can I say it? Like linear search or what? Or maybe we need to perform 2 times operation. First we'll just say we have this 1 and 6. Okay. And then all the numbers that are there, just will keep twice of them. So for example 4 to 8, 8 and 8 will be there. And then we'll start comparing with these two, and based on that whatever value that we count we are getting, that will be count, and after that we have to perform again the real sorting operation. And when we are doing this, so it will take order of n time storage, and here order of n. So 2 times we need to perform operations, but won't be that efficient. These numbers of this divide array into 2 halves and count the reverse pair while merging. During merging, count the number of z's where nums of I for I. Okay, I just need to take hint of it. I feel like optimal approach. In order to solve this problem in optimal way, use the concept of modified merge sort. Here the approach will be to check for every element in the sorted left half how many elements are in the right half also sorted can make a pair. Let's try to understand using the following example. Nums1, nums2. First element of the left half. Start checking from index 0 of the right half. For 13. Okay, so here we are just doing and I need to
So the last approach was taking n square, and we have to reduce it. So
man
we have
it's taking
to reduce it. It will be somewhere in log n or we go off n, and that is something we are getting as an input. If you remember in the last problem, count inversions, we did take examples where I was taking two arrays. So let's, for a moment, forget about this problem. Let's go to a problem where we have been given a couple of sorted arrays. Yes, if you see both of the arrays are sorted in an ascending order. So let's take this. And if I ask you for these couple of arrays, can you find me the number of pairs? Can you find me the number of pairs where if you take something from the left, that should be greater than whatever you're taking from the right array. For an example, if you take 21 from here, then you can pick up 2, and this can be a pair. 21, 1 can be a pair. 21, 3 can be a pair. But 21, 13 cannot be a pair because 21 is here, 13 is here. That's okay, but it's not greater than twice. So this cannot be a pair. Again, something like 6 and 25 cannot be a pair. Something like 1 and 9 cannot be a pair. Only pair is possible if something is from the left and something is from the right. Then only a pair is possible. Alright, so let's again go the same way as we moved in the count inversions problem. So we have two arrays, this one and this one. Both of them are sorted. So in the count inversions, what we did was we were basically having condition as array of I greater than array of j. So in a case where we were standing at 3 and we were standing at 6, we were sure enough that if 3 and 6 are compared, 6 is greater than 3. So thereby, all the numbers can form a pair with 3. Why? Because 6, 3 can be a pair according to this condition. Similarly, 13, 3 can be a pair, 21, 3 can be a pair, 25, 3 can be a pair. And that was only possible because this 3 was smaller than 6. Thereby, all the numbers on the right of 6 will always be greater than 3. That's why it was possible. And that's why we ended up taking the count 4 as the answer, because if 3 can form a pair with 6, it can form with everyone. But over here, that condition or that process will not work. Why? Because over here, 6 I know 6 is greater than 3, but I know 6 is not greater than twice of 3. Not. So 6 cannot form a pair, but 13 can, 21 can, 25 can. So you'll miss out. You'll miss out. You'll just take 3 and you'll move forward to 4. So you'll miss out on these pairs. The only reason it worked for this one is very straightforward. If 6 forms, these will form. But over here you have a condition. You have a condition. Will you write the condition now? You have a condition of array of I greater than twice of array of j. So it doesn't matter if this one is forming a pair with this one or not. Because if 6 is not the forwarding, the next elements might be. So you will be missing it. Alright? But you don't understand, roll back, watch it again. You'll understand for sure. So we cannot apply a method row extend. So addition of array condition is very straightforward. If 6 forms, these will form. But over here you have a condition. You have a condition. Will you write the condition now? You have a condition of array of I greater than twice of array of j. So it doesn't matter if this one is forming a pair with this one or not. Because if 6 is not the forwarding, the next elements might be. So you will be missing it. Alright? But you don't understand, roll back, watch it again. You'll understand for sure. So we cannot apply a method where we say if 6 is forming a pair and the others well, because that doesn't work. Because if 6 doesn't form a pair, the others might. So we will miss out. So we'll try to apply some other logic. Understand the logic will be slightly. We'll try to stand over here and see who can form a pair with 6. We will stand at 13 and say who can form a pair. We will stand at 21 and we will say who can form a pair. Let's start and then we will try to optimize. First I'm standing at 6 and I'm asking you which people can form a pair. You'll be like 1 can, 2 can. So these two people will definitely form a pair with 6. Right? So let me write this. 6 can form a pair with 1, 2. Not with 3, because it is greater, not greater equal to. Okay, let's go to the next. 13. Let's see for 13 who can form a pair. For 13, this can. Everyone this can. So let's write that. For 13, 1, 2, 3, 4, 4, and 5 can. Not 9. Okay, perfect. Let's go to the next, which is 21. For 21, which elements can? This can. Okay, can this still? So 1 can, 2 can, 3 can, 4 can, 5 can, 9 can. Perfect. Let's go to the next one, 25. For 25, who can? This, till here, not 30. So for 25, actually I can take all the elements and I can take 11. Do you see a pattern? You do. If 1 and 2 can form a pair with 6, I'll repeat. If 1 and 2 can form a pair with 6, they can also form a pair with 13. Why? Please hear me out properly. The reason is 13 is greater than 6. So all the elements that form a pair with 6 will also form a pair with 13, will also form a pair with 21, will also form a pair with 25. Because if 6 is greater than someone, 13 is bounded, 21 is bounded, 25 is bounded. So try to use this analogy that the same elements can be reused. If you see same elements are being reused, try to use this. Because as of now, what I'm doing is, for 6 I'm trying to find the keys. For 9 I'm trying to find some iterating throughout, which might end up taking a lot of time. So this is where, because it is sorted, I'll end up using a very simple formula. Not a formula, rather iterative thinking. For 6, let's see till which we can have an answer. This one can, and this one cannot. So I'll stop here. I checked for 1, it can. For 2, it can. Like I'll check for this condition. 6 is greater than twice of 1. 6 is greater than twice of 2. 6 is greater than twice of 3. So I stop here. So for 6, I stopped here. Can I say I will take 2 to my answer because of these two elements? I can. So I can. Next I'll move to 3. Now remember, you don't need to start checking from the first again. No need. Straight away start from 3. Okay, for 13, 3 cross 3. Yes. For 13, for 13, 2 cross 3. For 13, if I go here, 2 cross 4. For 13, if I go here, 2 cross 4. For 13, if I go here, 2 cross 5. If I go here, 13, 2 cross 9. No. So we stop here. It's not possible. So I go check, and this out, and this is where it comes out to be not possible. So all these elements are apparently possible. So how many elements do you get now? 1, 2, 3, 4, 5, 6. So 6 added to the answer. Perfect. Let's go to the next, 21. Let's take on 21. Again, see, for 21, you do not need to start from the first. You can straight away start from 9. You don't need to start from 1. You can straight away start from 9. For 21, 2, 9, yes, let's move. For 21, 2, 11, no. So you stop here. And you can say 9 can be taken. So apparently 7 elements this time. Perfect. Let's go to the next. 25. For 25, 2, 11, yes. So you move ahead. For 25, 2 plus 13, no. So you stop. So you moved ahead and you stop here. So apparently this time, 8 more elements. I'm done. So for every element, I figured out it can, like, how many elements can it form a pair with? And this will be my answer. The total will be my answer. There's those many pairs I can form from the left and from the right. Quite simple. It wasn't that tough. So this is what we will try to implement in the merge shop. Why? Because both the parts are sorted. And if you remember, where did we have sorted arrays? Right? Because the starting arrays definitely might not be sorted. So we know one thing for sure. When we break them down in merge shop, it gives sorted parts. So for every sorted part, I can compute the answer. The overall answer will be my answer. Similar to what we did in count inversions. Got this logic? So instead of relying on 2 pointers, I slightly changed the two-pointer technique, right? So now let's come back to our original problem. Now we did solve a different problem where we were given 2 sorted arrays. So if I have the original array, how can I take them to a portion where they have 2 sorted arrays? The best is to perform a merge sort because it divides, and then it auto converts them to 2 sorted arrays. So let's try to do it. So first, I'll try to break it down into 2 portions. And this portion will be 40, 25, 19, and 12. And the right will be 9, 6, 2. Let's try to solve the left part first, and then we can solve the right part. So this will be 40, 25, whereas this will be 19 and 12. Let's try to solve this. This will be 40 and 25. So let's first solve the left part, and then we will try to solve this. So we have 40 and 25. So if I try to write them separately, 40 and 25, just try to map this to this problem. Isn't it the same? 2 sorted arrays, find me out the number of pairs. Okay, let's try. We stand here for 40, it's 25. 40 greater than 2 or 25. No, so we stop here. How many elements before that? No, so 0 pairs. Let's go. Sadly, we got 0 pairs when we did 40 and 25 as two separate arrays. Perfect. But this step is done. This is a different step. This is not the same step. Please remember this. This is not the same step as merge. Once you have done this, then you do the normal step of merging, which is basically 40 and 25, which is smaller. 25, you take it, and then you take the 40. This is a completely different step. Please remember this is a completely different step. So I've got 25 and 40. So this time what I'll do is I will go back.
I
Try
think,
to change it to 25 and
okay.
so the left portion is done. Now let's go to the right portion. On the right portion, we can again go ahead and split it to 19 and 12. Perfect. And if I again try to write it separately because I'll have to come back. So whenever you're coming back from the merge shot, you know you're merging it. But before merging, you perform one small step before merging. Again, try to map it to the same problem we solved. For 90, let's try to find it out. Can 25 be? No, it cannot be. So apparently, anything before 12, like there are no numbers, so 0 pairs again. Done. Our step is done. Do the merge steps on merging, you get 12 and 19. So this will be 12 and 19. So I merged it. Perfect. Merged. What's the next step? This left and this right because both of them are solved. Try to merge them. So before merging, we will perform our step. So let's write them 25, 40. Again, try to map it to our problem. Can I map it to our problem? Yes, I can. Why? Because this is the left sorted array, this is the right sorted array. Let's try to map them. So for 25, if I try to figure it out, can 12 be possible? 25 greater than 2 twice of 12. Yes, possible. So I'll move to the next. Can 19 be possible? 25 greater than twice of 19. No, I stop here. It's not possible. So everything before 12, very important. Everything before 12 is possible. So I'll add 1 to my answer. I'll add 1 to my answer. Perfect. Bring up. Can I? Our step is done. Once your step is done, you simply perform the merge step, which is in the merge shot. Only 5, 40. So I can see that. So this will give us an again for 9, 6, and 6. When I try to move it, 2, 6, 9. Perfect. I merged it. What's the next step that you do? Once my step is done, you can merge them. So let's go ahead and merge them. What's the next step that you do? So let's try to merge them. And over here, get 12. So pair. Can it move ahead? Can 12, 6 cannot be a pair. So answer. Once you've done that, you can move it to 9. Ace of 9. Yes, that is possible. 3 to your answer. Finished. And then going ahead, you move to 4 and 6. Otherwise, you can merge them and the merge shot algorithm will also give you. Again, I'll not be reiterating on the fact that why does merge shot give you the answer of all pairs because I've already explained that in the problem count inversions. It's because it's very simple because 40 and 25 within themselves have got it. So now they're looking for the right. And with the counters, you have to perform back. This is usually mid. This is usually mid plus 1. And this is usually high.
Okay, I got the. Okay, so we need to perform 2 steps. I'm just curious to know more about it. So what we will do first is let me write down the algorithm for merged array. Man, can you just zoom out to 100%? Okay, I wasn't expecting this solution. Okay, so let's say we have numbers like okay. We have numbers like 6, 4, 1, 2, 7. These are the numbers. So what we will do, suppose we have array 1. Okay, let's just write down the merge step of merge and count. Okay, so when suppose we got array 1 and count 1 and array 1 is nothing but merge short, you can say, and array no, let's say nums and start mid and say like copy it, duplicate. So if you notice here count to 2 will be array 2 nums, here it will be mid plus 1 and end. So okay, these are the two values. Now we have sorted array 1, we have sorted array 2, and before we start to see how many elements are, so we'll start scanning the elements of array 1 and we'll see how many counts are possible. So can I say for I equals to 0 to, let's say n is nothing but len of array 1 and m is nothing but len of array 2. So okay, we have the length of n and m. So for, can I say I in range, that means n, so all the elements of n, and now we need to check in array 2. So j is nothing but equals to 0. Initially it will be j j equals to 0, while you can say array of 2 of j into 2 is less than array of I. So what we'll do, simply we'll do I plus plus, and so finally we got not I, j plus plus. Okay, so whatever the value that we are getting at j means we finally got the value that is greater than this value. Okay, so we can say finally we got the value array of I is smaller than array of j. Now before this j all the values are there, so we can say count will be nothing but values so far. So if j is 0 and we are at 1, that means first value is 1. So whatever the value we know, we are starting from 0, so the value will be I mean here if it is 0 and 1 and we are stopping it here, so we can say like there will be only one element, so you can say the value that is representing 1. So okay, I mean what I wanted to say, j is starting from 0, so the position where it will be also will represent number of elements before it. For example, if it is at 1th index, then there are one element before it because we are starting from 0. So if we need to count, we can say simply cnt plus equals to j. If it will be 0, then 0. If it is at 1, that means there are one elements previously that are larger, and we will add this count plus equals to j. Okay, and after that just follow normal merge operation. So you know how much time complexity will it take? We need to calculate it, right? So in the first case, first let's take example in the first element only itself. Okay, so can I say this one is going to iterate most of the time one time. So the complete will be order of n plus m, this one. And if you know that the second one, that is also order of n plus m. So order of n log n. Really? And now let's jump to the solution part. Why I wasn't? So we have reverse pairs, that's nothing but okay, let's say merge array and self nums start end, and this one will be mid will be if start equals to end, that means there is only one element, and we can say return 0 and you can say nums. Okay, we need an array, so nums of 0, not start, my bad. And finally mid will be nothing but you can say start plus end by 2. So we got the number mid and we have the mid value. Now we can you can say cnt1 and ar of 1 is nothing but self dot merge array merge array, and there will be nums and start end. Man, I just made a mistake or what? And cnt2 and array of 2 will be self dot merge array And bro, here we have nums start will be mid plus 1 and end will be end. Okay, end is not going to change for everyone. Okay, so here we have numbers, and finally what needs to be done, check the count, find the count. Let's say find the count bro. Okay, so for that we have to sort an array. So let's say I, for let me start I, let's say count equals to 0, and for, okay, for, or let me do one thing, count will be count 1 plus count 2, that is already there. So we'll start with I in range. Okay, let me do one thing, n will be len of array of 1 and m will be len of array of 2, while I in range, you can say n, then j will be starting from 0, j equals to 0, and we need to add 1, while array of I, j less than m, and array of I is greater than array of, no bro, array of 1 of I is greater than array of 2 of, you can say j, 2 into, that means the numbers are, this number is larger than the twice of these numbers. So far if the number is greater than this, we'll do one thing, j plus equals to 1, we will keep on doing this, and finally the count will be, okay, we will do one thing, count plus equals to j, we know j will be the count, and if it is 0, and finally we got the count. So count is nothing but this, and we need to merge the array. So array 3, we can say, and what should I say, I equals to 0 and j equals to 0, and while I less than n and j less than m, that means both are in the range. So we need to say if array of 1 of I is less than or equals to array of 2 of j, so we are reassigning the j value. That means we need to, so array 3, I will never forget, I don't know if I'll forget in future, but for the time being, append array of 1 of I. Okay, so we need to advance the value of 1, and else, that means if it is smaller and array 2 is smaller compared to array 1, that means you can say arr of 3 dot append and array 2 of j, and we need to advance j plus equals to 1, be cautious man, and we do not know, while I less than n. Okay, so array of arr of 3 dot append, you can say array 1 of I and I plus equals to 1, while j less than n, j less than m. So array of 3 dot append and array 2 of, fuck you, sorry, I'm really sorry. I do not know what I said, I just in flow मेरे मुंह से निकल गई. I'm sorry, just in frustration I said, so maybe beep, but I'm not gonna edit, it's live and really sorry. Yeah, I need to change my habit. Sometimes in frustration I just say it, but no, I do not mean it. So j, and yeah, really sorry. I do not actually I feel bad what I said in that social media. Okay, so I less than n. Okay, I plus equals to 1 means we are advancing I by 1, j we are advancing j by 1, and while it is this, and finally return, you can say cnt and arr of 3. So we got both, and now we need to do one thing, that is this bro, you need to written, and you can say CNT, and result is nothing but self dot merge array, and you can say nums and 0 to len of nums minus 1, and that's great, and return CNT. So we just want to okay, great, we solved this with the help of tutorial, and we were I'm sometimes I feel like I need a little bit more confidence to uh, solve the problems and all. Okay, so here we go. So we finally finished it, and I just will I'll add note and will shut down my computer and my brain both will shut down. So solve it with the help of tutorial, and moving forward I am expecting you to solve it without any hint or solution. Okay, and that's pretty much about it. My palm, not palm, it's upper of the palm is like itching, so I do not know what went wrong now. So finally it's great, like I can see the 100% progress here, and that's what we like it. I like it. Okay, so for the day we made some progress. Not I'll say we made pretty much progress and all, because no, we just solved one problem. And let me see what is next. I mean, we need to come back to it, and I'm expecting second time maybe binary search will do. Bro, these are the playlists. So first we have covered array. Now time to go to binary search. I know how to binary search algorithm, so we need to brush up and all. So we'll cover this DSA playlist, and after that maybe we'll see any other stuff, or maybe we'll deep dive and we'll solve lead code problems. It's up to us, or it's up to the plan. Until we are not feeling confidence, system design seed. Okay, we need to use it as well. Like, what are the concepts? Definitely, it will be pretty much interesting to learn these. What are the basic concepts? And so, and let me be honest, still I do not know how things are working. It's like most of the things are black box to me, and that's why I feel like I need to learn more. So then only I'll be a good engineer. Otherwise, it's like I'm just know some tools how to use them and all. Okay, so that's pretty much about the self-reflection and discussion, and now I can sleep peacefully. Rest in peace to others. My bad. I always have a habit of stopping a video, but here we can't stop from there. I can't stop, not we. Stop streaming. Thank you. Bye bye. Good night.